This is my sixth and final video on analyzing graphs of functions, in which we're going to explore what we mean by even and odd functions. And this is often a confusing point for many people, but it's pretty easy to kind of understand once you get the hang of it. So we're going to start by talking about even functions. So you'll notice I got a couple of bullet points here. Starting with this one here, we say a function y equals f of x is even if and only if when we plug in a negative x value into it, we get the same thing as f of positive x. In other words, if you were to plug in a negative x value, you get the same y value as if you would have plugged in a positive x value in the first place. And you'll notice also here that I say even functions are symmetrical with respect to the y-axis. So what we're going to do is we're going to go ahead and take a peek at this function here I've got a graph of. This is an even function, or example of one. We notice that it has y-axis symmetry. So the first thing I'm going to do is I'm going to say, well, how do you identify even functions graphically? We say it's even because it has y-axis symmetry, okay? The other thing that I would like to indicate is that we have an algebraic check for this. So what makes an even function even? Well, talking about this algebraically, basically what we're saying is if you were to take some positive x value, say x is 1, and plug that in, you would get this point here. We would say 1 comma, f of 1 would be right here. What if, however, we were to take this x value, which is positive 1, and plug in exactly the opposite, negative x, or negative 1? Well, going left on this graph, you'll notice that if I were to plug in negative 1, I get f of negative 1, but essentially negative 1 comma f of negative 1. What I want everybody to notice is that f of negative 1 is the same exact height as f of 1. In other words, to plug in a negative x value gives you the same thing as if you plugged in a positive x value. So in order to check to see if a function is even or odd, we're going to find that out here in a second, but what we're going to do is we're going to plug in negative x. So in other words, find f of negative x. We're going to find this. And we say 2, if the same as the original expression, okay, then it's even, okay? In other words, what we could do to check to see if this is even, and we could say, well, let's plug in, positive 1 and negative 1 and see that we get the same output. We could plug in positive 2 and negative 2 and see that we get the same height, and positive 3 and negative 3 and we'd see we get the same height. The idea is this: instead of plugging in every single negative x value to see if you get the same thing as every single positive x value, we're going to plug in infinitely many x values at once. So we're going to find f of negative x right up front. So what I'm going to do is I'm going to give an example of a purely even function. This is a very even function to kind of explore. This is f of x equals x squared. And this is very easy to determine because it's just a parabola. I already know that this has x-axis symmetry. So if I were to type in x squared and go take a look at this graph, we know that we have our parent function of this quadratic thing. We can obviously see that it has y-axis symmetry, so this is definitely an even function. The whole point here, though, is for me to show you how would I determine this algebraically, which is what you're going to have to be able to show me. So to check this, what we're going to do is we're going to find f of negative x, and we're going to say, what would this give us? And this is easy to do. We'll plug in a negative x wherever we had our original input x's, and we'll say, well, what's going to happen when you square a negative value? Well, we know what happens when you square a negative value. It comes out to be positive. And I want you to notice that x squared is the same thing as this original f of x. So in other words, we were able to show that f of negative x equals positive f of x. All I really want to point out, though, is this. We say it's the same expression. Okay, it's the exact same expression as the original. So these are kind of fun to play around with. If we were to give one more example of this here, we could dream up many even functions. As a matter of fact, here's another easy one. We'd say maybe x to the fourth minus x squared. I know that when I plug in negative x values here, that fourth power and second power, in other words, any even exponent is going to square a negative thing and pop it back to being positive. So let's go ahead and check this algebraically. Our check is to plug in a negative x value wherever we see an x value in the original expression. So plugging this in, what we see is we get negative x to the fourth minus negative x to the second. Of course, when you take a negative thing to the fourth power, it comes out to be positive again. So we say positive x to the fourth minus. Now this negative's out front of this squared term. So when I square just the x value here, it comes out to be a positive x squared. So we're taking away a positive x squared. And what I want you to see is that this is the exact same as the original f of x. And so we have proved that this is an even function. And what I would like to do is go ahead and take a look at the graph of this. We say x to the fourth. I'll go ahead and type in x to the fourth power minus x to the second power, x squared. And we'll take a look at this graph. You'll notice that we get something that is obviously symmetrical with respect to the y-axis. So this is an even function, okay? So let's go ahead and take a look at odd functions here. I don't mean to have this on here, so I'm going to get this out of here for you guys. We'll delete, if I can, this right here. Yes, and what we're going to do is we're going to pop in the definition of an odd function. So I have that screenshot here. Here we go. An odd function. So if I copy and paste this in, thanks for being patient with me here. Odd functions. This is what I wanted to have in here. But essentially, what is an odd function? We check it very much the same way as we check an even function by plugging in a negative x. But what you'll notice this time is this: we say, whereas an even function, we said f of negative x implies that we get the same as the original. Okay. What we're going to see here is when we plug in a negative x value this time, you'll notice we get negative f of x. In other words, negative the original expression. So we're going to say that this is the opposite. This is the exact opposite of what we started with. And what I would like to say about their graphs is that odd functions are symmetrical with respect to the origin. Now, when we say symmetry with respect to the origin, what we're saying is, given, if it is an odd function, we say given some point xy on the graph, we're going to say it implies that negative x comma negative y is also on the graph. So I've given an example of an odd function down here. We can see that this is a function symmetrical with respect to the origin, but the reason why is because, let's go ahead and say I choose this random point here. We say that I get x comma y is on my graph. Well, I notice that if I were to put a negative x, negative y, I also land on my graph. In other words, let's say that this is the point, hypothetically 2 comma 1, then the point negative 2 comma negative 1 would hypothetically be on my graph. That is what we mean by symmetry with respect to the origin. It kind of folds over the origin. So what we're really saying with odd functions is, if you were to put in a negative input value, you would get the exact opposite y value as if you had put in a positive input value. Okay, so to check for an odd function, we're going to check it the same way we do over here, except for this time we're going to say if we get the opposite expression, then it must be odd. So I'm going to give an example of a fairly odd function. We say, notice that the exponent is odd. This is a good way to remember whether things are odd and identify it functionally. But we say, let's check this for even or oddness. So the nice thing is we check it the same way you do an even function. We say, let's go ahead and put in negative inputs everywhere I see an input value. So when we plug in now negative x for our input value, I want you to notice this: when you take a negative thing to an odd power, you get the opposite, or it stays negative, I guess, is this. And what I want you to notice is that we get negative x cubed, but what do we know about x cubed? X cubed is f of x. So in other words, we got negative f of x. So this would verify that this is an odd function, because when we put in a negative x input, we got the opposite. This is the exact opposite of the original relation. And that's easy to see algebraically as well. We say negative x cubed is the opposite of positive x cubed. So really quickly, what I'd like to do is we're going to go ahead and put this into the calculator here. We say, what if I were to put in x cubed, x to the power of 3, go ahead and hit graph. And I'm going to hit my trace key here. The reason why is because when you hit trace, let's say I hit 2, it says, well, x equals 2. When I hit enter, it's going to say, well, when x equals 2, your y value is 8. What if I were to say trace and I want to put negative 2 this time? What if I put in a negative 2? Well, then I should get negative 8. And you'll notice that this kind of folds over the origin here. So really quickly, let's go ahead and say, well, could I generate an odd function just right off of the top of my head? I can think of a really odd function. We say x to the 5th minus x cubed plus x to the 1st. You'll notice that all of your exponents being odd actually corresponds to it being an odd function. When we plug all of these in now, we say blank to the 5th minus blank to the 3rd plus blank to the 1st. And we fold in all of these negative x's here. We're going to notice that all of these negatives being to odd powers give us this new expression, negative x to the 5th minus negative x cubed, which would be positive x cubed, plus a negative x to the 1st, well, in other words, minus x. And I want you to notice that this here is the opposite of the original. Okay, so if we were to take a look at its graph, we'll see something that has symmetry with respect to the origin. The best way to kind of learn about these is kind of try to make up some of your own functions here that happen to be odd. So x to the 5th minus x to the 3rd plus x. and then go graph it and see what you get a graph that looks like here. And we notice that we get this thing here that is symmetry with respect to the origin. X to the fifth minus x to the third plus x, okay? Now, one really quick thing I want to do is I want to say, well, what if I were to put a squared on this last one here? Now I've got even and odd exponents. Would this be even or odd or neither? When we go look at this graph this time, you'll notice that it's not quite symmetrical with respect to the origin. So hypothetically, if I were to go back and put in a squared, then you would notice that I would get a new expression here that would give me negative x to the fifth plus x to the third, and this plus negative x squared, that actually would have made this a positive. And this right here is not the same as the original. It's not exactly the same as the original, okay? Sorry, this would be squared. And it's not exactly opposite either, so this would be neither. So this is what we mean by even and odd functions. Cheers.